all the way down, because it's going to just perform the same calculation all the way down, and it stops, the value is less than our original value. So we know that all of these numbers are in between 7.6 centimeters and 13 centimeters, okay? So now our time of flight can be calculated. If you look at our time of flight, it's this long equation. It just refers back to column E, okay, column D, and column G. So we've augmented column G with our assumption. I'm just going to go ahead and fill and pull this down, okay? And we can see that all of these numbers are negative, and they decrease as the angle decreases, which makes sense. It should take a shorter amount of time to shoot backwards and hit the table than it does when you shoot forward. So that is fine. And then we're going to do the same thing for this particular column, time of flight, for the negative solution. And you could see that these actually increase with time, which makes sense, okay? And so now we can actually predict our x displacement. So when we predict our x displacement, we have only a formula, and we're referring to column A and we're referring to column C, which are back here, column A and column C, the angle in radians. So let's just go ahead and make this prediction. This is a theoretical thing, so that means that it's still a guess, but it's a pretty good guess. It's an educated guess. So you see that it's increasing. It doesn't go over, which is still making sense. Right now, we are in our measured x displacement. The measured x displacement is something that we actually have to acquire, okay? So we have our first one. It actually comes from 0 degrees, and this is our average x displacement. And then we have, let's go down here. We have 0.83, and this is coming from 20 degrees, okay? So you see that we have 0.83 right here. So let's just go back, and now we can predict what's happening. And you know what I'm going to do, I'm just going to double click on hypothesis. Well, I'll do that next. Let's go ahead and copy our angle in degrees. We could literally just move it over if we wanted to. It might throw you if you're on your desktop, but you can literally move it over. We don't need to have excess amount. And I'm going to place this right in between time of flight and predicted range. And it's not going to mess up any of our calculations. So now if I went to angle in radians, you'll see that Excel has changed the calculation here from B2 to I2, which is super, so we don't have to duplicate anything. So now we want to make a plot between these two columns. So the angle in degrees is going to be on our x-axis, and the predicted x displacement is going to be on our y-axis. Very important to know, okay? So let's just go ahead to insert and insert a chart. And let's call this an XY scatter here. And here we have our XY scatter chart. So predicting the x displacement, let's just call it using, and let's get rid of that meter there, using the technique of interpolation. And so, of course, we want to make sure that we have this chart labeled properly, which means that our primary horizontal axis will have a value. We know that this is our launch angle. So I could just put in angle, but launch angle is very descriptive. And so let's do that. And we know that this is in degrees because that's how the column that we used. So launch angle in degrees, very descriptive, okay? And then for the primary vertical axis, we are going to call this predicted x displacement. And of course, this is in meters. So we want to be explicit about that. And if you guys wanted to, you could, of course, move this to another page if you like. But this is good.